Uh, Hope you had a good breakfast. So, we will be having a very energizous sessions today. So, in the morning for the first session, we have Shri K.N. Keshav Prasad, founder, Shilpa Shrungar, consultant architect, Bangalore, Karnataka. We heartily welcome on the behalf of Department of Civil Engineering, Jyothy Institute of Technology, Bangalore. So, I would like to request on this note, Dr. Shri Keshav to have a briefing of his profile.
Good morning, all. So, I firstly welcome K.N. Keshav Prasad, founder Shilpa Shrungar, on behalf of Jyothy Institute of Technology and AICTE as well as ISTE for accepting our invitation with respect to this 1 week FDP program to sharing his thoughts. So, K.N. Keshav Prasad is finished as a B architect from Malnad College of Engineering, Hassan, Karnataka. Worked as site architect in Shilpa Sindoor at the year of 1989 to 1991. And in Shilpa Sindoor, he involved in construction of residential building using stone slab building materials. And also he worked as chief architect in Development Alternatives NGO. In this particular NGO, he involved in the design and execution of several projects using cost-effective technologies. The particular technologies which include stabilized mud blocks as building material, composite masonry using stone and brick, random rubble stone masonry, fill slab roof, and construction of arches, domes, walls, and jack arch roofing. Especially these are very much related to our particularly civil engineering uh, things. So, and also he designed a village in Latur. So the thing is, when earthquake happens, so on that time, particularly sir involves in the design of villages which include 55 acres, all civil amenities and 360 dwelling units. And also he worked as consultant architect in Action Research Unit, which he involved in the preparation of report of housing action plan for the year 2000. This report is submitted to government, which provides statistics of existing housing of Karnataka and design concepts of future projects. And also sir involves in different phases, and also he just started a Shilpa Shrungar for in which in his own foundation he's constructed more than 500 plus projects which includes hospitals, residents, apartments and resorts, villas and indoor sports centers. The firm which taken up projects on turnkey basis using alternate construction technologies, especially those constructions are developed using our basic alternative construction technologies, in which he used hollow clay block masonry, wire cut brick masonry, side stone rubble masonry, stabilized mud block masonry, filler slab roof using SMB, glass and hollow block walls, glass brick roof, and skylights. And also, sir is having teaching experience at various institutions, includes Malnad College of Engineering, Hassan, MSRIT, Bangalore, as well as Acharya Institute of Technology, Bangalore. Welcome you, sir. I hope all participants are getting benefits of this particular lecture session. Thank you for being a part of this event, sir. Please go ahead with presentation, sir. Thank you, sir. Sir, please unmute and
Yeah. Oh, thank you very much, Dr. Keshav. So this is an opportunity for me to spend few minutes with you all. So thank you very much for the faculties and head of the department and also principal of Jyothy Institute of Technology for giving me an opportunity on the occasion like this. Thank you very much. So I'll continue with my presentation. I'll just share my screen. So basically, I always believe a picture worth 1,000 words. I do less of talking, and everybody can understand. If at all there is any confusion or any clarification required, please do let me know. Let me start with saluting all my gurus so far, whoever has imparted their knowledge in me. And my list of gurus also include all of you, because everybody, because of you only I prepared this. I try to learn so many things. You are also in place of my guru. Thank you very much. And we'll start with just a salute to all my gurus. And yeah, and thank you very much for being here, my respectful audience. I respect your talent, and those who are young, you get plenty of opportunities in future. Those who are already in the teaching, in the teaching profession, we also want to learn a lot of things from you. And as far as possible in this presentation, we are just talking from basics, so that the clarity in basics always helps us to move further. And I'm talking in general what happens in this particular field of architecture and civil engineering, and how we are going to move it to the future.
Sir,
So
as a
basically,
small request, sir. Sir,
yeah,
can you please enable full screen, sir?
full screen.
Slideshow.
There is a problem. I tried.
Yeah.
Yeah, slideshow. I tried
Uh,
doing that, and the screen goes blank.
uh,
So that is a problem.
sir, is it possible to click on this slideshow, which is on the left top of your? Uh, y-
Yeah, yeah, yeah.
yeah, yeah. We'll try one, sir.
This one, no, right?
Yeah, yeah, yes, sir.
You're trying. Yeah, 1 second.
Play from current slide. Yeah.
Yeah.
Sir, I think, sir, you can click OK once over there.
No, the thing is coming on my computer. There is a problem.
Okay. Sir,
Yeah. So
yeah.
shall I click OK?
Yeah. No issues, no
Yeah.
issues. I think it has exited the sharing. Sir, one thing I want to suggest: when you're sharing the screen, please share the whole window than PPT, sir. Then it will be shared easily. When you're sharing the screen,
Okay. What should I do now?
you have please click on share screen and select for
Yeah.
share whole window rather than PPT. Share whole window of your laptop. That will be the left
No,
one,
where is
left top one.
left top one? Yeah.
Yeah, yeah,
Okay.
yeah. Sir, don't send. Now you can click on your PPT, and now you
Ah,
can click on the slideshow. I think it will work now. Click on the
shall I
slideshow.
click on the slideshow?
Yes. Okay. Okay, sir, we'll do one thing. We will maximize the PPT. Sir, you can click OK again.
Yeah, nothing is coming on my end. Just I have
Yeah,
to
yeah,
wait.
yeah. Sir, you can just click OK again, sir.
Yeah.
No
Okay.
issues, no
Right.
issues. Yeah.
Yeah.
Sir, you can click again. Don't send. You can continue like this only, sir. But please
Okay.
maximize the window for
Yeah.
better visibility to the participants.
Yeah.
Yeah, yeah.
Yes.
Yeah, to the full extent, please maximize the window, sir. Sir, you can please continue the presentation, sir. Thank you so much, sir. Yeah. Sorry for
See,
interruption, sir.
no. See, the title being past, present, and future. See, basically, in past, present, and future of the construction industry, especially in India, we will try to understand one by one. There are plenty of slides. I want to go fast, and if it is too fast, please do let me know. So India is full of natural materials. So we get plenty of materials in India. It is so rich in its resources, so that as engineers and as architects, it is a pleasure for us to work with so many materials which are naturally available in India. And if you want to go for the definition of the past, it is truthful, it is necessity, and it is invention. So basically, necessity is the mother of invention. So when we start with the past, basically it is a settlement-based living, and wherein you always tend to explore how you are going to construct your buildings with the locally available material. And whatever the past which is there, it was contemporary at that particular point of time. Now it is past. For that, it is taking the word which is called as traditional. But past, whatever the technology that they were doing at those times are always termed as contemporary at that particular period. And it is generally the settlement. So once the settlement comes into a place, what are the things they are looking in that particular area is, one is the natural resource, what are the materials available around that particular place, and then the climatic conditions, is it livable or it is extremely hot or cold. Depending on the climatic conditions, the settlement used to identify the place to start settling in. Then water is most important factor in for any settlement. If water is abundantly available, it is used for the normal living and also used for other activities. So then another thing is the fertile soil. So a settlement always looks for a fertile soil to do agriculture as a part of their regular activity. And then materials, land and labor, all these things were available in those times. So land was abundantly available, no problem. And now labor was also there and materials were also there. Then it is a time to start building up our shelter with whatever locally available. It started with this: use the forest, the dry wood, whatever it has been fallen from the tree, and start constructing the shelter. And natural building material is mud. So they used to use sun-dried bricks to construct their own residences. And in hot and dry climate, they used to use mud as the roofing material, not only for walls, they were using also for roof, so that thermally it is more comfortable. And usually the thickness of the roof will be nearly about 1 feet high, and every year they used to do surfacing to maintain that particular roof. And then stone was available. This is a typical stone shelter where there is no leakage, absolutely there is no problem, and it is long lasting. So it is very hard materials to work with, very nice material, and which is quite natural. And the tribal people always used to make a cave in the forest or wherever they used to settle, and that is the most very well protected shelter. And then you have the thatch, the dry grass which is available. They used to use that particular thatch for their roof in those times. Then the building technology started developing. This is the wattle and daub construction, wherein you have this particular the vegetation, the dried vegetation. On that they have to just plaster it with mud. This is a typical wattle and daub construction which was locally available in those times, and they used to use stone as the basic foundation. This is for the wall. And then you have the wall constructed of adobe blocks. Adobe blocks is nothing but the hand tamped bricks using the locally available clay. So then you are coming to another system which is called rammed earth wall. They used to mix mud with little bit of pebble, make it harder, and build the wall accordingly. Nowadays also people are again trying to reinvent and stabilize the mud with cement and using the same technology. This was there at that particular point of time. Then you have the stone wall, the rubble stone, whatever is available, and that is the wall thickness always used to be very thick, and the locally available material and its natural finish always giving a wonderful appearance for the building as well as the architecture of at that particular period. And the initially built forms started, the structural safety was the key factor. Then came the planning aspect, because anything whatever they used to build, whenever you see the old buildings, the walls were thick, the structure was solid, and the structural stability was of main importance in those times. Then followed with aesthetics. You have the stone pillars and the stone slab as a roofing material, so that there is nothing is going to happen and it is long lasting. And this is a typical stone column and roof in those times. Then you have this particular roof which is made out of the slate formation. For example, you might have heard about the Shahabad stone or the Kadapa stone, whatever is available. So using those slabs, they used to make a roof so that it is locally available and it is just used like a Mangalore roofing tile. This is the stone, and then started how to span the openings, the windows. In a mud construction, wherever we go to a village, you see smaller windows. It is very difficult to span windows in those times when they are using mud as their building material. Stone, then they just started using the arches. Arches can take the load. At the same time, you can keep bigger openings so that you can get a lot of light and ventilation to your buildings. Then the structure again, the column and the stone slab on top. Here you can see there is a column here, and this particular capital, again, it is one monolithic stone which acts as a cantilever support, which is always called as the corbelled stone, which will support this beam at the top. And then on this beam, these stone slabs are rested. Then this is a structure first, and then the ornamentation started. Wherever you see the column, this is ornamentation, nothing but aesthetics. So these are the temples which were there at those times. Then stone for bridges. They used to use stone to construct bridges in the water. Absolutely, stone was, wherever the stone was available, they have made use of that particular natural material abundantly for our convenience. Then after the discovery of fire, fire plays an important role. Once the fire was found, so everybody started putting something into the fire. So you may remember when we were kids, whenever we used to see fire, we used to put whatever we have. Either it may be a paper or it may be anything. Possibly one of them might tried putting some mud into the fire, and then sort of that it became very hard. It can withstand the water, so that then they felt the need of the burnt bricks so that they can use for outside wall. It can be protected from rain as well as from sunlight also. So this is a typical burnt brick which was there at those times. And then the country tiles, they used to burn the tile and put the roof accordingly. And then comes the Mangalore tiles which we normally see. This is also a burnt clay. And then the brick arches. Once you start burning the mud, so it becomes solid. Various types of arches were found out and incorporated in the traditional building system. So this is a segmental arch where the center point is at the bottom half near the flooring, and then you have a keystone here, the key brick basically, which will take care of the load and try to distribute all along the wall. And then the climatic conditions played an important role, where you have hot and dry climate, flat roof with mud roofing system. And then this is a typical photograph from a village near Yadgir. There is a place called Bengaluru. Bengaluru is a place which is around 35 kilometers from Yadgir, where it was, this particular village was located near a stone quarry, and then lot of neem trees were there. And this is the kind of architecture or the civil engineering you are seeing in that particular village, which looks like a modern building. You can see the random rubble masonry, you can see the dressed masonry because labor was available at those times. Then you can see the steps, the cantilever steps, which we use in modern times, which was existent at that particular point of time. These stone slabs were inserted into the wall and it acts like a staircase. So this is the photograph of a old village near Ergi. Then when you come to the rainfall area, like all the South Karnataka area, wherein you have tiled roof. And this is the rammed earth with the stone base, and then layer by layer, they used to make this particular wall, and it used to go to the height of minimum around 20 feet and withstand. This building is around 100 years old. And again, in hot and dry climate, you see this slate roofing. It is again in Yadgir district, one village in Yadgir district, which has a courtyard. And this is use of country tiles along with the wood, whatever was locally available in those times. This is the wood for construction. Even if you want to go for the next floor, the first floor, they used to use wood as the understructure, use the wooden column and make it to take the load of the first floor, so that building one story above the existing ground floor or above two-storied building became possible with the use of wood. Then because of these technologies, the plans were made in a linear way. So everything again depend on the local technology, and the planning was basically on the technology. So this is called linear planning, wherein the spans are less. You can span it the way you want. This is the maximum span. This is a plan of a church. Whatever the building is, the span should be less so that it is easy for them to put the roof, whether it is stone slab or whether it is mango tile roof, whatever it is. If the span is cut down, then it is easy for you to plan. Even in civil engineering, we talk about economical spans. What is the economical span? If the width of this is less, then it is easy for you to do the structures. If the width is more, then you have to adopt lot, you have to do a lot of calculations so that the structural stability of the structure is not disturbed. This is what the three-dimensional image of a church, wherein you have the columns everywhere, and then it is a frame structure altogether. Then the linear planning continues. This is the inside of a nave and the sanctum, and the people who are in the hall, they used to use this particular space. They used it for a larger project. And whenever you see a church or any old building, it clearly expresses the structural stability apart from aesthetics. Aesthetics took a second seat because the structural stability, then the ornamentation begins. See, anyhow, these minarets are there. Then designing it, giving it a shape is a different thing. But planning wise, the structure important, aesthetics became a part of ornamentation, and the window shapes were different. Here you see the pointed windows, here you see the semicircular windows. There are so many things happening in the old buildings, but creativity was not at its best. Structural stability was the key factor. Then uh, the dome as a roofing material was an alternative, a brick dome. Then it gave a tremendous amount of influence on the planning system. So once the dome is invented, then the total planning changed. From linear, it became symmetrical, so that the planning changed because of this particular technology. So the dome became the center, and then the ornamentation started. You lift up the dome after a certain height, put the windows here, and do whatever you want in terms of painting and all these things. This is a vault, whatever the vault, that also they used to span, because arch is the vault is a development of an arch. This is a dome, which is a semicircular dome, and you have the skylight on top. This is the aesthetics, again structurally more stronger. Here you see the column, and the columns are distanced at 8 feet regular intervals, the structure, and then it gets transferred here and then onto the ground. And with this background, we will just go on to the present scenario. What is happening now? So, and now present scenario is, wherever you see, whatever you do, you see only people. Apart from people, there is nobody else. Now it is a population explosion. So, and we know about our schooling system. Our schooling system, initially it was a Gurukula system. Now we have a schooling system. Unfortunately, the kind of schooling system what we have is this. Our education system is like this. Without understanding the students, without understanding their capabilities, we try to teach one common syllabus for all, so that what will happen is that personal evolution, once you cannot focus on the kids, it is always difficult. Again, depending on the market, they will choose their options. And then we move on to our professional courses. Now, the new materials, whatever that is there in the market, is the present day. You have a cement, and you have steel, and you have the concrete. Concrete is a wonderful material. The great architect Le Corbusier described with one word, calling concrete is a plastic material. You can mold anything you want using concrete. The introduction of concrete played a tremendous role in architecture. So what happens once everything is possible with this material, there is nothing that it is impossible. So everything was possible. Then the architecture started its evolution. So design creation, you start with the design, because everything is possible. Once you design it, execution is always, there is scope. You can do whatever that has been given as a part of creativity. So that is the basis of architecture. Now, in the present day, it is a design first, structure next, and comes the execution. That is the sociological changes we had in our society. Then the structural design. You create something which may be free flowing, or it may be rigid, or it may be large span structures. Everything was possible with the structural design. Steel was available, concrete was available, cement was available. Then the construction, the cost of the construction, and the labor management, all these things became part and parcel of the civil engineering industry in the present days. Then you have one more particular segment which is called as project management. It is not only the owner, contractor, and architect, it is the overall project has to be managed in giving a proper schedule and completion of project on time. This is one more one more field in which very much professional services are required to execute a project, larger project. And there were more opportunities, which is equal to more possibilities. And expectations were very high in the present day. Whenever you go, whenever you meet a person, he will say he has a tasteful, he wants a tasteful space. It is not that any shelter with 4 walls and 1 roof, that days are over now. Now they want something beyond that. And architecture is nothing but a creative profession. Now they can create whatever they want. And from here, there is a freedom and creativity. I will go to some of the architects who have designed in the modern times as per their wish, as per their creativity. This is one church designed by Le Corbusier, was designed the Chandigarh city in India, and he called the concrete as a plastic material. So even the walls were slanted, walls were curved, and the roof itself became a boat-shaped roof. With concrete, it was always possible. Then this is Frank Lloyd Wright. He went on to design. This is a Guggenheim Museum, which has all the ramps. This is basically the artwork display center. So you keep on moving along with the ramp, and you have the display so that you are moving gradually to number of floors. This is a free-flowing design. Then you have, this is the TWA Airlines designed by an architect called Eero Saarinen. So it is looking like a bird. Airport looks like a bird. All these things were possible because of invention in the material which is available. So, and there is one more architect. Regarding this architect, I have to tell you. So basically this architect has a peculiar concept. Each architect comes out with the concept of designing something different. So he used to fold the paper and throw it, and looking at the kind of foldings that particular paper used to have, he used to design the buildings. This was his conceptual approach. And the building were also like this. So it is that way, this way, and all these things. You cannot call it an octagon, you cannot call it a circle, it is half circle, half octagon. All these things were possible because of the materials available. And these are the buildings he used to design. You don't know which is front, you don't know which is back. So absolutely, there is always a scope to design whatever you want, and execution became more challenging. To build a building which is like this, you have to plan it. Your structural engineering is a must. Quality of workmanship is a must. So it is a challenge for the engineers to execute this kind of project, and it was possible. They are doing it. So absolutely, the whole building concept, it is totally different. And then you have the Sydney Opera House in Sydney, which has a shell shape. If it is outward looking, it becomes a form like this. The form is innovative, the form is different. It is all, everything has to go onto the ground for its load distribution, but it is possible because of these materials. If the form looking outwards, it becomes Sydney Opera House. If it looks inwards, it looks like a Baha'i temple. So all these options. So you take the concept from a lotus and start building it. So once you have concept ready, building is absolutely no problem. You can always do it. And you have one more architect, Zaha Hadid. She is known for her creative work. It is all free-flowing structures, absolutely no problem. Never used to think about how it is possible. You design and the engineers will make it possible. It is, as engineers, it is our challenge to execute the building, whatever the design has been given to us. And you have skyscrapers, you can design the way you want. You might have seen so many skyscrapers with lot of shapes and forms. So, and then you can see the skyscrapers need not be vertical 100% 90-degree from the ground. It can take any shape, but the top end and the bottom is going to be in line. So basically the gravity you had to work out, but the challenges is accepted. You give the design, I'll execute it for you. Then you have this wonderful architect called Laurie Baker. He used to work in Kerala. And that is one segment, whatever we have spoken so far. This is locally available material with simple bricks. He made it to look so elegant with all this perforated wall. Hot and humid climate, you require the air to pass through. This is all climate responsive. And then he came out with the idea of using the locally available material in Kerala. He has done, this is the Center for Development Studies in Trivandrum. So he has done wonders using those materials. And here is one more architect, Gerard Di Cunha, who has designed Nrityagram with the, it is one of his work, it is his office. So basically what is happening is, so this particular cantilever is supported with the wall. So you use the modern kind of structural system and with the locally available materials, and this is called corbelling. Gradually the load from the top gets distributed to the bottom, and this is a different kind of architecture with the modernism with the traditionally locally available material in Goa. And this is Achyut Kanvinde, who has designed GKVK Bangalore, and this is Jawaharlal Nehru Sciences, and all these things which you are seeing, the top cubicles, it is the climate responsive. It is in Delhi. So these are all the wind catchers, so that the wind will be driven down to the building, so that the internal space always gets the wind. It gets cooled here, and this is called the passive cooling, so that the whatever the wind you get inside the building, it will be a cool wind. And this is Shankar and Navnath Kanade, who used to teach us. They came out with a different technology using stone slabs. You have these concrete pillars which measures 11 inches by 11 inches. They have the groove on all the four sides. In those grooves, all the stone slabs were inserted and made it to look like a wall, wherein your foundation cost is only for these pillars. Even the foundation was also just you excavate until wherever you get the hard soil, then put the stone slab one above the other and start building this particular concrete pillar. So this is the new technology. He is practicing now. Navnath is practicing in Bangalore. They had the firm called SHILPA. So I got an opportunity to work with them and executed these buildings, and it was really fantastic. Natural materials and stone slabs are used for these pergolas. And then now it is not, home is not a shelter, it is a tasteful living. So basically you want your building to look different. So how to make it different? All these are all plant truss. Once the vegetation goes on top of this, the whole building has a greenery in it. And then this is the expectation of the present people. They want strong buildings. They want cheap and best. Everything has to be cheap and the best quality. It is not going to happen that way, but still the expectation levels are that. Maintenance-free building. They want adequate light and ventilation. Aesthetics. It has to look different. That is the end of it. No need to look old or new. It is different. Some people may want a building to look old. Some people may want their building to look different. Then you have this Google influence. Everybody goes through the Google and say that's what they want without judging themselves. What is their liking? They see the picture and they started liking the picture. That is a different thing. But you should know, basically our education system fails this way because we don't know what we like. If somebody asks you a question, what are you doing? What is your basic strength? Nobody is in a position to reply confidently. How strong are you from inside? But we are always influenced by something we see, something, even though we may not feel, only the photograph will judge our taste. Then it is go digital. Everywhere it is a home automation system, everything on hand. So wherever you are, you can operate your house from your mobile only. Those are the general expectation. Then it is the learning with natural material. The present day, whatever we have learned so far. So and we just alternate technologies. We use the natural material, we come out with the alternate technology. First, it was termed as low cost technology, and everybody felt that low cost technology is not a good word. Then it was replaced by cost effective technology. Then some people felt that that is not that kind of a level. Then you call it environment friendly technology. If at all you ask anybody, some rich people, they say, I have a farmhouse which is built out of environment friendly technology. Then it was termed as green buildings. Then it was called as energy efficient buildings. All these are all terms which was used to construct the cost, the cutting down the cost and using the locally available materials. This is the modern day hut. This is a Krishnagiri thatch, this particular building in Jain Farms, Bangalore. So this is how they use now at present they are constructing. It is a stone and the mud wall, it is a stone random rubble masonry. Here if you go, it is just a wall with mud plastering. It is a traditional hut we had seen in our earlier past days. It is for now fanciful living. I had been to a resort. I spent wonderful day in a hut. That is our explanation of richness. In those times, those who never had money or whatever the locally available material, it is a necessity, they used to live in a hut. And this is the technology we are talking about. We are just redoing the same thing. It is a brick dome, brick wall, and a rubble masonry. This is the stabilized mud block wall. This is a random rubble masonry. This is a composite masonry. You use dressed stone outside and stabilized mud block inside. You have this Kadapa slab louvers. And this is a vault. Below this, there is a pond, so that these perforations will admit a lot of air from outside. This is facing southwest corner, and then drive it down on top of the food so that the air gets cooled and then moves around the inside the building so that the internal ambience or the atmosphere is always healthy. This is a dome, 22 feet wide segmental dome constructed using brick, 4.5 inches brick wall. This dome was done without centering. There was a telescopic guide which will give you the particular shape which can revolve around, and also you can always stretch it. So using that mechanism, this dome was done. And this is a dry arch, an arch without any cement, any mortar inside it. Because of its form only, it takes care. This is below the vault. I was telling this was a pond. When the construction was on, this was a sometime. Now, after that, we converted that into a pond so that the air comes on top of this, and this was spanned using these arches here. And this is the brick jack arch roof, wherein centering was not necessary. You have these T-beams on top of that. This particular brick was laid in the form of an arch. This is called brick jack arch roofing. And this is the stone slab. You use the stone slab to do your staircase. This is simply supported and it will go, and there is a stone slab here. That's how it creates a lot of usable spaces inside that. Instead of having concrete, it is just a brickwork and stone slab. And this is the screen wall, where this is actually a residential dormitory for a training center where they keep their luggages in these racks using stone slab. It also act like a curtain wall. This is the farmhouse. The farmhouse was given with the basic concept, my house has to look old. So that was a concept. Yes, fine. We will use everything is a hand plastered wall here. The corners were rounded off, and then this roof was made with a split opening in between, which acts like a breathing roof. So that internally everything aeration will be great. So you feel it is very cool, and this is how the concept used to be derived. And this is the glass tile with Mangalore. This thing, that particular house in the center has a courtyard. The overall light comes from these glass Mangalore tiles. And then the stabilized mud block. So this is, we use the modern cement to stabilize the earth and use it for residential buildings. In a residence, the whatever the foundation soil you used to get, you make use of that and make a stabilized mud block and keep it exposed. So this is 5% cement stabilized mud block. You take the mud, weigh it here, and then this is a press used to make these blocks. And these are all the arches made in mud block. This is all exposed mud block only. So you can make arches using stabilized mud block. And this is the stabilized mud block house with terrace gardening. This is present, it is happening if the owner has a passion to grow some things on his terrace, because the land space is not available to that extent where they can grow vegetables and all these things. Here, the owner was very much fascination towards agriculture. He was from a village, so he is maintaining the whole system. This is stabilized mud block with the then this filler slab roof. Usually there is one particular point whenever you design a RCC roof. You have a neutral axis, invisible neutral axis in the RCC flat roof. The bottom of the neutral axis will not carry any load. So replace that kind of concrete with any cheap material so that it will reduce the dead weight of the roof. At the same time, it becomes economical. We try to do it in one of the buildings wherein this is the filler material, which is 2 inches in its depth and it is 9 inches by 9 inches. And we just made this particular mold to get a floral impression in the block itself, so that from underneath it looks like a false ceiling. So this is how the reinforcement is less. Everything is around 1 feet by 1 feet. And this is a 22 feet by 22 feet hall with a pyramidal roof. And here, basically, these are all stabilized mud block arches. This is 12 feet span. This is 8 feet span. This is a marketing center, which is where we have done that particular filler slab with the skylight on top. And this is how you see from inside. Usually all this pyramidal roof or dome, it is not good for acoustics. If you use this filler slab, these mud blocks, you can be used for a good acoustic material which absorbs the sound waves, and very well suitable for a seminar hall. And it gives the space feeling. At the same time, you can always play with this particular material. And in the residences also, you can use these mud blocks with the same thing. This is the filler slab roofing. We try to use it in our buildings. Then we come to the use of stone. You have seen the dressed side stone masonry. Now it is a random rubble masonry. Random rubble masonry gives a natural finish along with this hollow clay block masonry. It is a combination of different material to make it look different. It is natural, but it is worked out in a pattern so that everything goes along with the natural material. And here, the same clay block used as a column. So used as a column to support the pergolas on top of this, the clay block pillars. Basically, these were different use of the clay blocks. So you can use the same material in different kind. And the mirror, you can use the mirror, the present day modern material, just a reflection. You don't see your face, that anyhow you're going to see in your dressing room. But here in the living room, when you're there at the first floor, you can see the ground floor. When you're in the ground floor, you can see the first floor. And then in the first floor, normally what happens, there will be a cutout and skylight on top of it, and there will be a railing around that cutout. So what this railing will do is that it will break the whole space into 4 or 5 spaces. So instead of that, if you use glass floor flooring, this is a laminated glass which has 2 glasses with a mat in between. You get this floating effect. If you switch on the light on the ground floor, it can illuminate your first floor. And this is our small office space wherein we have used the clay block, and this is the clay block pillar we are talking about, which is a load bearing wall. This is the hollow clay block which can make, where I am sitting right now, which can make the interior cool because of that particular hollow. And then we are using along with the hollow clay block, we are using the glass which will act like an illuminated wall. Wall is no more a dead wall. Wall also says something. It can admit, like where you cannot provide opening, you can always insert glass. This hollow clay block along with the glass will not allow any water to seep in, so that your wall can sing a song if you are inside. And this is another wall which is used for this particular project with lot of glass. And here you have a dressed side stone masonry, a composite masonry. Here you have a wire cut brick masonry, and again you have the stone slab pillars and the pergolas are on top of it. Here you can see this is all the stone slabs, and then the pergolas were supported on this particular girder, which is I section girder, on which all these stone slabs supported. We use the natural material along with the MS girders. And then you can see the whole masonry with glass. Your horizontal is a glass, vertical is a glass, and the whole wall, the clarity in terms of the joint, the mortar joints. So it is a load bearing wall. So absolutely there is no problem. This was built around say about 8-9 years back. So absolutely there is no problem. No water comes in. And then we use the glass bricks as a skylight option. So options are plenty. You just slant, because in smaller houses there are only 3 feet gap left. So you just slant this particular wall using the RCC as a material, and then this particular opening at the chajja level, you can always put these glass bricks and get a dramatic effect inside, so that this particular light will remain undisturbed throughout the day. So if the neighbor construct his house living 3 feet, from the window you will not get any light, you get only ventilation. From the skylight you can get lot of light all along the day. This is the glass brick vault roof. Try to insert glass bricks with the curved roof so that you get abundant light and it is more secure. Nobody can enter through that, but the water also cannot come in here. Concrete and glass, they go very well. So absolutely, that considering the temperature coefficient and all these things, this was constructed around 8-10 years back. So far we have not received any complaint. Try to play with the natural the glass getting light from the top. And this is one more building where the glass bricks are used abundantly. And this is another house where you have free flowing pattern wherever you want, where this is the cantilever. From here to here it is almost 8 feet cantilever slab, and then this is the bedroom on top, which also opens. There is a opening which also open on living room double height, so the space filling is felt. So bedroom no more remains a room with 4 walls. It also, when you want maximum light or a visual connection between the living room and the bedroom, this is possible. And then we use the glass tubes for interior. The glass tubes for interior, it is fine. So nowadays it is available, and for exterior it is even looks better. So nowadays it is more challenging for us. It is not only you design the building on a daylight. Whenever you see outside, it looks nice. During festive occasions, whenever you're there, so whenever you want to see your building, always say something during morning, also during evening. So all these LED lights, glass tubes can be used in the build form. That is possible because of the material which is available to us now. And then you have the terrace garden in an apartment. So basically, because you don't have much space, wherever the space is there, try to put a lot of plants where they give the oxygen, and then you can always have a healthy living. So terrace garden to another core, because you have used the land, that much land has now taken over by you to build your particular building. Then terrace, as far as possible, you try to use the terrace for gardening, so that whatever, to certain extent, you can always compensate. So then we come to the future. This is the present, the future. What is the future of built forms? The built forms are always, it is basically, when you talk about the land use, you cannot occupy the whole land without leaving any space for vegetation. So you may have to go up vertically up. So then what will happen, if there are a lot of people around, everybody wants to build their own houses, there won't be any land left for greenery. So we'll see the future. There is no limitation for creativity, and there's ample scope for research and building material and technology. You can use the natural material, come out with a product which can be used and which can be recyclable, and we'll see what are the challenges that is there in the future for us to go into this particular profession. And more scope for structural design, because everything is free flowing, everything can do it. So absolutely, sky is the limit. The limit is infinite. You can work, you can always put yourself under maximum test, so that you can come out with a wonderful solution for the structural engineering, which will always makes the engineer happy and also the architect happy, and the building remains stable. It is more challenge for the structural designers. And then for the builders, you have the technology, you have everything, you have drone, you have all the machineries. So we'll talk about that slightly, in the next this thing. So you have the machineries, and all these things are taking over gradually, because though the good project, a good built form is nation's pride. Whenever somebody show Bangalore, they will always immediately show Vidhan Sabha. It means it is Bangalore. Whenever they talk about the Parliament House in Delhi, it is they show the building and try to identify the name. So what happens? A good project is the nation's pride. And then the challenges in the construction industry. You have to use biodegradable material. You have to recycle the material. That is more important. Rather than use the plastic and throw it away, it will not go anywhere. It is not biodegradable. Then it should be climate friendly. When you start using, nowadays apartments are constructed using RCC walls. In a tropical climate, the problem with RCC wall, which is 4 inches thick, is during daytime it is absorbs a lot of heat. During night it will radiate. So basically, as far as the tropical climate is considered, you use a good thermally comfortable material. It should be climate friendly, energy efficient. There is always a debate when we talk about energy efficiency, where the people those who are using stabilized mud block, they used to talk that we are environment friendly, we are using the soil. And all this other people, they used to argue against it because you are destroying the topsoil. So it is useful for agriculture purpose. If the soil available from the project itself, it is fine. When you excavate for foundation, it is fine. If you are getting it from somewhere else, then the problem is you are destroying the top layer of the earth. So that argument is always there. Then if you start saying I am using stone, then people will say you are using stone, you are destroying the whole landscape, which is very much essential as far as the natural material is considered. You are destroying that. So anyhow, so then the land use, you have to be careful. You have to give some land so that the rainwater harvesting, whatever the water conservation you are doing, you build in your land. Make sure that whatever the water falls in your land will be absorbed in your land only. Then you have to use less carbon footprint. All our lives are in danger because we smoke carbon dioxide in cities, especially in Bangalore. If you are in the center of the city, the land value is high, but the kind of living you are doing, it is in the carbon dioxide only. Better to go out where you get the pure oxygen. Then easy to adopt, make it flexible. Everybody can access it. Nothing solid engineering is required. Make it simplified so that everybody can adopt. Then water conservation. One is the rainwater harvesting, another one is the wastewater management. You can always purify this particular wastewater management. And when we were designing a house in Latur, the concept is whatever the bathroom water, whatever the kitchen water which used to be led into a pit which has a kind of vegetation. That particular vegetation normally you see around a lake. Those roots will have a purifying system so that you feed the water from one end and then the vegetation is on top of that. Then it will pass through all the roots. Then whatever the final product which comes out of that particular this one, the particular channel, will be a pure water. Reuse it. So don't depend on whether you're in Bangalore, don't depend on BWSSB, try to get your own water. And now we started getting our own electricity by solar electrical, and we are also using solar battery for our electricity for our household. Try to use these are the challenges which has to go hand in hand. You should not work like the normal. At present we are working. BWSSB handles separate, KEB handles separate, BBMP handles separate, the plan sanctioning authority is separate. All these people, they have to go hand in hand to make these things possible. So for the time being, our challenge is to link all these things together, come out with a possible good option. Our present scenario in the construction industry is chaotic. The Mestri is a good contractor. we have a lot of competitors. Those who are not studied civil engineering, they are also contractors. Those are the Mestris become a good contractor. The mason will become a Mestri and become a good contractor. So there is no particular qualification required to do a contract. So we have a lot of problems. So we are facing the labor problem, and we are facing all those things in the present scenario. So we have the building industry, totally unorganized sector. Now with the mobile on, each and every person carries a mobile, including the students to the workers. Everybody is happy in seeing the video on the mobile. Morning to uni, you are the favorite students of all of us, are favorite students of WhatsApp University. You just keep on seeing the video, your day is done. Finally, end of the day, you think, what have I done? There is no achievement, no learning, nothing. Finally, you have spent the whole day in front of our mobile, and lethargicity. Nobody wants to work hard. So that is the unorganized sector. Then lack of natural resources. We don't have a natural resource at all. So absolutely there is a problem. So we have to just address this. So you can cut a tree, provided you should plant a tree, or you make the tree to grow and cut the tree which is already grown, then replant it. Then this is the Mallasandra stone quarry, which is near Bangalore, and all the stones were taken out, and finally instead of stone you see water. So end of the day, this is a disaster. We are destroying the whole nature, but for our greed. The Vikasa Sauda was built using this particular stone. What is the need to replicate the Vidhana Sauda and build one more building which occupies the same area in the heart of the city? And that particular building is a Xerox copy of Vidhana Sauda. Once Vidhana Sauda is there, why to make a Xerox copy? And it has been copied along with its mistakes. Only that will serve as a landmark. But why do you want to copy? Present day technology is available. Use less space, create more space to live in is the challenge, whatever we have. Then we have labor problems. See, we have masons working with us from last 18-20 years. Their children are not becoming masons. A carpenter's son is not becoming carpenter. So what will happen? There will be a scarcity of labor which will be taken over by machines. Now, to build you have machine, to plaster you have machine, everything is machine oriented. There will be less labor. Labors are not at all available. In the present scenario, the cost between, if you give it on a labor contract and if you go for a prefabricated structure, it may be around 10 to 15%. Prefabricated structure is more. Gradually, the prefabricated structure will cost you less, then the availability of labor availability is going to be difficult. And then demand for pre-made materials. I don't say pre-cast. Pre-cast means concrete. So you have to derive a solution for the future, which is environment friendly, pre-cast, and then the whole building is built. There is a demand. We have to work out a technology where the engineers going to be of crucial importance. And without engineers, you cannot build. So in that case, what happens? From an organized sector, you become more organized and protect green belt. Wherever it is there, protect the green belt, develop it, give a lot of vegetation, and then reforestation. Start doing the forest rebuilding. Wherever you see a barren land, try to plant something, make it green. All this green will make our life easier and healthier. And then be conscious about environmental issues. So far, we are totally ignorant. We say we want our building to be done. Don't bother. Anyhow, material is there, use. So that kind of awareness has we should come out of that awareness. Whenever you do something, you have to think globally and act locally. So that's what the knowledge is important, attitude is important, values are important. Then environmental conscious makes your life better. And then you have to strike a balance with nature. Without a proper balance, it is very difficult for us to survive. Then the disaster may happen. So, like whatever happened now. So, we have to strike a balance, live with the nature, part of the nature, don't destroy the nature. And with this, we are going back to our basics. We have to be truthful. If it is necessary, we will do it. And the necessity is the mother of invention. With all this thing, we have to go back to our basics and lead the future without any this thing. And we are always moving towards a better living with all these things in our mind, awareness in our mind, and we find out a lot of things in future which will be used, and we'll see a wonderful green future in front of us. Always make it a point. You should always remember the past and enjoy the present. Your body will be there, your mind will be somewhere. So whenever you get up in the morning, you always think that what is there in my WhatsApp message. So nothing is going to happen if you don't see the messages for a day or two. But keep your mind present always, so that your mind and body will be always pleasant. Enjoy the present moment and then plan for the future. So what is important for future? You think, you have the education, you have the job, you have sports, you have love, you have family, and your food and health. Everything becomes part of you. So you can plan the future if you are actively present in the moment. So with this, I conclude my presentation. Any doubts, any clarification, do let me know. So thank you very much once again for all the faculties and the principal and HOD of Civil Engineering and Jyothy College for giving me an opportunity. Thank you very much, all the participants. If it is useful, it may be of some kind of a satisfaction for me. If it is useless, please excuse me. Thank you very much.
Sir, thank you for a marvelous presentation, sir. Sir, we have a couple of questions from the participants. I would like to put it in front of you, a couple of them. Sir, what is the most efficient or effective technology of water conservation, and
Yeah.
how it shall work for the society in construction?
Yeah. See, water conservation, effective and the easiest method is groundwater recharge. Why groundwater recharge? There are two things. One is that whenever you do a building, one is you collect rainwater and start using it. So what will happen is that you have to filter it, and then whenever there is rain, there is no scarcity of water. But at the end of the day, when end of the project, whenever you are going for groundwater recharge, you have to make a pit and make whatever the terrace water that gets collected go into the pit, and that helps in the groundwater recharge. That is the easiest and economic solution, so that the water falls within your site will be absorbed in the ground. If you go for collecting, if you want to make a sump tank to make that particular water useful for you, so minimum in a 40-60 site there will be 2 lakh liters of water gets collected in that particular terrace area. So if you start making the sump tank which is 2 lakh, one is space is not there, second thing is the money will not be there. Try to make use of the groundwater recharge. Wherever you see now, groundwater recharge is not only pertaining to the building, but whatever the road, whatever the tar road you are putting or the concrete road you are putting, so that has to be led into a place, get it purified, and then it has to be absorbed in the ground. Wherever you see water is flowing and going somewhere, better you make the groundwater recharge with the recharge pits. That is the most efficient and economical way as far as the owners are concerned, as far as the government is also concerned.
Sir, we have a couple of questions from the in-house participants. I would like to provide space for them right now.
So there are few questions asked by our in-house participants. You explained different types of plans in earlier days, or nowadays we are using linear and symmetrical. Uh, what are other types of plans generally adopted in construction practice?
Yeah. See, you're talking about plans, right? Plan, PLAN.
Yes.
See, basically, I have to tell you, just because I'm an architect, the architects are crazy. Crazy in the sense, if they're happy, they will design it in a different way. If they are sad, they will design it in a different way. There are so many concepts. If you just try to put everything in a concept, one is the free flowing pattern. It can flow in any direction. There is no reason why they are doing it, because everybody wants their building or the design which is developed by an architect to be different. So you have a free flowing pattern, you have a abstract, which is need not be a rectangle, it can be anything, an abstract pattern, it can be symmetrical, it can be a unbalanced kind of a design. There is no limitations for your creativity. When the imagination takes place, there is no definition, this has to be like this. But as far as if you try to induce certain principles where it has to become economical, if there is no budget limit, sky is the limit. If there is budget limit, then you can think of economically span building and adding use of natural materials. Then you say vernacular architecture is the one, and then modern, whatever the contemporary architecture, another one is called minimalism. What is minimalism? Simple straight line. So with simplicity, but simplicity is not ordinary. See, most of the people, you may think, so I have constructed my house, I never went to an engineer, I never went to an architect, I constructed in a simple way. That is not simple, that is ordinary. What is simplicity is, it should go through the complicated process, then arrive at what is basic minimum needed. So that is called minimalism. Simple things looks good, but it is not ordinary. So simplicity, you have a rustic finish. Rustic in the sense, it is whatever the word comes to your mind in terms of feel, that can become a concept. There are plenty of varieties.
Yes, sir. One of the participants, YS Suhas, is posting like, I feel that our Indian codes have to be revised for the design of special structures where architectural aspects are much more inward. Is it so, sir? He's posing a question. He's expressing his opinion. So
Yeah,
he's posing a question to you, sir.
yeah, Suhas, it is good that the code has to be revised, but there is no systematic, in the sense you have to think that as far as the architecture is concerned, there is no particular method where you stick onto a system where you finalize the code. If the architect comes with a huge cantilever, and then the structural engineer can make a code for that particular work that may not be implemented by another architect. So what will happen is that the creativity, you cannot streamline the creativity. It again, your mind works on the data you have collected so far. You have seen, you want to do something different, you want to stand out, you want to make something phenomenal, and all these things. There is no prescriptive method for creativity. Unless and until you have certain methods for the normal construction, you can work out a code. But for creativity, architects design according to their crazy thinking, then it is always difficult for us to make a code in the civil engineering, which will always a challenging task. You cannot streamline everything, putting into this particular building comes in this zone, this building comes in this zone, and all these things may not be workable because you are thinking, well, from nowhere. I don't have any idea. Suppose tomorrow you want to construct a house. So you go to an architect. So he will design at that particular point of time, or depending on his previous buildings, he want to do something new. So for that something new, which nobody knows, it is very difficult to come out with a code.
So one more question from the participants. Most of the architect prefer alternative building materials for construction. What about
Ah,
structural design point of view? Those constructions are safe.
yeah, alternative building materials, absolutely there is no problem. We have seen the raw mud brick in a village which stands for a period of 100 years without any problem. If you even now, the villages are under transformation from the old structure to the new structure, because through the mangrove tiles or through the country tiles, there will be a lot of insects coming and all these problems are there. But there is absolutely no problem as far as the structural safety of any building technology that has been evolved after a number of years. See what happens when you construct a wall using any material, the RCC roof load, if you are using RCC for the roof. So what happens, you have to see that the ground, whatever is there, where the foundation is there, that has to be hard enough. This wall is just like a broker, or yeah, it is a broker which transfers the top load of the roof to the ground absolutely without any problem. So this is more important. The hardness of the ground should be strong. Suppose if you use stone with any kind of cavity inside the earth, in the sense, if there is a well which is existing earlier which you don't know, on top of that you construct your wall, whatever the material strength, but your foundation, the bottom portion of your foundation is not good, then the building will collapse. Otherwise, whatever you use, in our office we have used hollow clay block masonry, and the load distributed to the bottommost brick will be 1 kg per centimeter square, because the load keep on distributing between all the material that is there in the wall. So the ground has to be hard. Any technology you can use it, which should withstand the water, the heat, and all these things. Absolutely, there is no problem.
So one more thing that
Yeah.
is, sir, today it seems that the FAR floor area ratio is varying from builder to builder. Do you recommend or quote anything on FAR which is given in bylaw?
See, basically, bylaws are made at present. Unfortunately, I have to say this: the bylaws are there in the books. Most of us, including me, we are not seriously think about the bylaw. Your FAR, it has certain rules and everything is very well worked out. But the problem is, none of us are really onto it to follow FAR, because everything depends on the road and your side and the height of the building. Everything is revolves around that. Nowadays, gradually, once RERA is in picture, those who are making an apartment and all these things, they are conscious. Now, Karnataka electricity, sorry, the BESCOM is working in tune with the RERA so that you don't follow the bylaws, the electricity is not given. So, following the bylaw is essential, especially in a small site. If you are talking about the bylaws, nobody wants to leave 3 feet in all the sites in a 30-40 site. Everybody wants to deviate. Even though you take oath, in the sense you have to give it in writing for the BBMP authority, saying that I will supervise the building without any deviation. So instead of leaving 3 feet, they will leave 2 feet. So that is, we have come to that particular uh, segment wherein living the bylaws in the initial stage, it was extremely difficult. So always we used to find living only 1 feet or 1.5 feet. But now awareness is much better. Your neighbor always says, give me the sanction plan before you start the construction, or you better take this particular plan to your neighbor, say this is the setback I'm living. So basically that awareness is that you better follow the bylaws and make it strict. So nowadays it is slightly has the loose ends. We have to tie it out because the bylaws are made. But only the thing is that once the bylaws are made, it has to be finalized in the presence of the engineer and the architect and explain them why they have made the bylaws. That kind of transparency is not there now. Better we get, once we get transparency, it is all participatory. So everything becomes streamlined.
Sir, even is a architecture is a part of civil engineering, or civil engineering is a part of architecture. Why we are having separate design like school of architecture or separate in the civil engineering domain?
Yeah. See, the basic difference between architecture and civil engineering, one is they are in the dream, and you are the people, those who get all those people back to down to earth. So yours is the totally in architecture. We create building patterns, but we may not be able to execute. For you, more important than dreaming is execution part of it. So for execution, you require a different kind of intelligence, in the sense a different kind of experience. And it is not only you are building, you are also doing so many other things. One is the structural design, another thing is the labor control and getting a good quality workmanship. See, it is civil engineering, as far as I am concerned, everything, architecture and civil engineering, both hand in hand. If you study architecture, see, one person can become expertise in one thing. You build or you create. If you start creating and building, there are so many aspects in which I was one of the key members to handle end-to-end project. We start with architecture and we do the construction also. Then I found it so difficult to handle the financial matters. One is the finance, another is the labor component, another is the technology, another one is the material available, and another main headache is the owner, whoever builds. So to handle all those things, if you want an architect to do all those things, then architect may not efficiently create. The creation should happen with a free mind. With the financial burden on his head, he cannot create. So as far as the architecture is concerned, he knows basics how the building stands. But as a civil engineer, it is more depth towards the implementation of the dream. So there are many challenges that itself becomes more depth oriented subject. So the importance of civil engineering or structural engineering, everything is so important. Without them, none of the dreams comes true.
Sir, there is a question on glass wall. Is there any minimum thickness of glass to be provided in the joints? Will they be able to take the load, sir?
Yeah, see, basically in any construction, in any wall, you suppose if you don't use glass, assume that you don't use glass, you use mortar. Mortar does not carry any load. Mortar is a gum which binds the two materials, whether it is hollow block or it is whatever it is. So the glass, whatever you are using, it should be as big as the size of the block. Suppose if there is a clay block which is 8 inches by 6 inches height, you have to use to the all along the thickness of the wall, so that whatever the light comes from this side will always pass on to this side, so that the size, you can always vary the thickness of the glass. It may be 12 mm or it may be 10 mm, depending on the kind of aesthetics you are looking at it. You can provide any glass, but it should be entire thickness. But glass will not carry any load. It is just a binding between the clay blocks. Clay blocks are the main load bearing wall.
Yeah, sir. There has been we have been getting a numerous response from all the participants today on your talk, and we are very thankful to you for providing such an insightful presentation. I think I want to place a few words before we conclude this session. It it is very complicated to make some things simple, yet it is very simple to make something complicated. But yet the simplicity is the best. So this is what we can get the thing from your end, sir. And I think as an architect, when you dream of a structure, it is always we are fascinated as civil engineers that it look any structure will look so beautiful, and it is also a challenge as well as a duty and responsibility to make that structure happen, and workable to be constructed in that manner. Then only we will be able to construct some beautiful things around the world, or else we will be constructing some boring buildings, and there will be no much some beauty in going back to the home or going back to the office. We will be always be fascinated to visit some beautiful places as similar to the of the buildings that we are going to construct. Definitely we will be in line with the all the architectural fraternity to make more such beautiful structures happen on the earth, sir. Thank you so much for your presentation, sir. On the behalf of Department of Civil Engineering, Jyothy Institute of Technology, Bangalore, I would like to conclude this session. Thank you so much, sir.
Yeah, thank you very much. All the participants, always with you all, try to learn more things along with you. Thank you very much.
Thank you very much, sir. Thank you.
Okay.
There is an announcement for the participants. The next session will be at 11:30 a.m. from Dr. Arvind Bhashyam, Professor, Christ University. The topic is some interesting design aspect of super stall structures, Taipei 101 and Petronas Tower. Please have a break of coffee for around half an hour, and let's join back to the session exactly at 11:30 a.m. and let's continue this talk in the break of half an hour. Thank you.